In this problem, we have this tower that is connected with three cables, cables AD, AC, and AB. Now in this problem, we're told that the cable AC, this yellow line, has a length of 70 feet and a tension of 5,250 pounds. Now we want to determine the force exerted by the cable on point C. So point C is down here. And we also want to figure out the directional cosine angles of this force. Now I'm going to clean this problem up a bit. On paper, I would redraw the problem, but on the computer, I'm just going to hide the non-relevant cables to this problem. When I hide these cables, okay, now we have one cable and we have a bit of information, and this should be right here, 50 degrees. So we have this information and it becomes a force along a line problem. So it's a 3D problem of a force on a line. And what is the force along a line? Let's look at the equation we have. We know some force is equal to the magnitude of a force times some position vector of that defines this line. So I'll just keep it as r over the magnitude of this position vector. And this is the equation we have for force along a line. And right now, we know that this length right here is 70 feet. And we know this force, and we'll call this TAC, is equal to 5,250. Now, what do we need to do? Well, some of this information we can put directly into this problem. This is the magnitude of our force. This is the magnitude of our position vector of this line. So we know that this right here is the magnitude of r. This right here is my force. So I can say that TAB, this vector, is going to be equal to this force. So 5,250 times whatever this position vector is, we haven't found that yet, divided by 70. So we need to find this position vector, then we can find the force that this cable exerts on point C. Let's look at finding this position vector. To find this position vector, we need a vector that points from C to A. When we have that, if let's say what point A is. Point A has a distance of, look at the x, y, z, x, y, z. So 0 in the x, I go up 56 in the y, and I go up 0 in the z. So 0, 56, 0. And point C, well, we're going to have to do a little work to figure this out. We go over some distance in the x over here. So that's some distance. Then we go up 0 in the y, and then we go some distance in the z over here. So we'll need to figure that out. And really, the trick of this problem is figuring out how do we find those distances. Well, if I look at the force from this direction, and I will draw this. So this right here is some, we'll call this some length RC. Going up, I have a length that is 56. And going across, I have a length, or this hypotenuse, a length that is 70. So to figure out what this is, I can use the Pythagorean theorem, and I can reverse the order of terms, and I'll have RC is equal to the square root of 56 squared, or 70 squared, minus 56 squared. So this length right here is equal to 42 feet. So this length right here, right in here, is 42. Now that doesn't really help me Because this doesn't tell me how far I go in the x direction and the z direction. But I can make different triangles. I can make a triangle that looks like this. And then I can know how far I go in the x direction and how far I go in the z direction. And this is also going to be a right angle triangle. So let's make this triangle. Let's give this some color. Let's say this direction is orange. We'll say this direction is red. And we will draw this again. So I'll draw this, which is, I'll call this Z. That's how far I go in the Z. Then this is how far I go in the X. And the hypotenuse is that 42 feet that I just found. Now this angle, well, I know that this is also a 90-degree angle, so this angle right in here is going to be 40 degrees. So this right here is 40 degrees. Now, okay, I have the hypotenuse and I have this angle, so x is going to be equal to 42 times the cosine of 40. Z is going to be equal to 42 times the sine of 40, and let's calculate those. So 42 cosine of 40 down here is going to be 32.2 feet. And 42 sine of 40 is going to be, we'll round this to 27. So x is 32.2. Y is equal to 27. And we can figure out what this vector r is. How do we figure out what this vector r is? Well, r is going to be, if I look at this force along the line, and this is position C, my force extends this way, and it goes to A. Now, A has these coordinates, 0, 56, 0. C has these coordinates, 32, 0, 27. So now to find this position vector, we just need to subtract C from A, and we'll have this is 0 minus 32.2 I plus 56 minus 0 J and plus 0 minus 27 K. So this is minus 32.2 I plus 56 J minus 27 K. And if you take the magnitude of all these numbers, you'll get 70. So this is just a good check. Minus 32.2 squared. Oops. You need to put that in parentheses if you're going to use the minus signs. Plus 56 squared plus minus 27 squared. 40. You can see right now it's going to be really close, not exactly 70 because of some of the rounding we did, but we get this magnitude's about 70. So now we can put this into this equation. We can say TAB is equal to 5,250 times minus 32.2 I plus 56 J minus 27 K over 70. And we can calculate this. So this calculation becomes, this is equal to minus 2,415 I plus 4,200 J minus 2,025 K. And this is going to have a unit of pounds. So this is the force that the cable exerts on point C. So now we just need to figure out the directional cosines. And we have equations for these. So if I start with the cosine of alpha, and this is going to be equal to, well, what do I call this? It's the x component, so alpha goes with x. So this is going to be equal to, we can call this just in general terms, this AX, and this is my position vector over A. So this is going to be this part of the equation right here. So minus 32.2 over 70. To get alpha by itself, we're going to need to say, all right, then alpha is equal to the inverse cosine of minus 32.2 over 70. And this is 117.8. Okay, we can do the same for beta. And the cosine of beta is equal to AY over A. And so we use this part of the equation. So this is going to be equal to 56 over 70. So beta is equal to the inverse cosine of 56 over 70. We get 36.9. So this is equal to 36.9 degrees. And then finally we have gamma. So the cosine of gamma is equal to AZ over A. That's this part of the equation. So this is equal to minus 27 over 70. So gamma is equal to the inverse cosine of minus 27 over 70. And this is 112.7 degrees. So there you go. These are the directional cosine angles. So alpha is 117.8, beta is 36.9, and gamma is 112.7.